Guys, welcome to another geography lesson with Mr. Clark. We're going to have a look at some more river features. Again, a quick reminder, normally 8 marks a feature, 4 marks for processes, 1 mark for a list of unnamed or unexplained processes, but when you're explaining them, make sure you talk about how they work, where they're working on the feature specifically, and use your diagrams and labels to do that, and really make sure you said how they change the feature shape, and you'll do that within the model answers I give you here. So make sure you give examples of features. It's good practice, but remember it's probably not guaranteed to get you marks like within coasts and glaciation sections. Don't forget marks for processes. They're really key. We have noted these in the last lesson, so if you need to double check those, have a look at the river processes and waterfall PowerPoint from last time, or the Loom presentation like this. Okay, so go away, watch the 2 videos here. You don't need to take notes, but do have a double page in your jotters or on your A4 paper. Make sure you're going to go in landscape for taking notes around of your diagrams with notes around them. I'll explain those as we go. The first video is from BBC Bitesize, so if you click on this picture, it will take you to the web page. You'll have to scroll down and have a look at that 40-second video. And the second video is from the same person who gives you a video out of waterfalls. It's based at GCSE level, so a little bit lower than higher, but it's really good for consolidating your understanding, and it is in quite good detail. So it kind of gives you a visual idea of what we're going to be talking about and how we're collecting our marks. And I guess with this, the kind of key things you could be talking about a little bit different are the fact that freeze-thaw weathering happens here. Freeze-thaw weathering, some of you will remember that from National 5, particularly from the limestone topic, is literally when water gets into cracks. It expands by 9% when it freezes. So ice will expand by 9%, and that causes, if it keeps happening time after time after time, so over hundreds of years, it will happen thousands of times. Each night it will drop below freezing perhaps, then bits of rock will break off, and what we're having, because we've got these steep slopes, that causes material to fall into the channel, and gradually that turns our valley into more of a V shape. So, and the videos will explain it, as will the notes we look at here. Right, you're going to take a note. You've got several diagrams. I'll quickly show you them here. You've got 4, 1, 2, 3, and 4. So leave your space in your jotter for 4 main diagrams. There is a little diagram on the left there about interlocking spurs, so I wouldn't necessarily mean you have to note that down, but the video will show you a picture of that as well. So the 4 main diagrams, and we'll just kind of go over those, and you can ask me any questions on the Google Classroom or send me an email, and I'll answer any questions you like. So the key thing for this feature that will pick you up a mark are saying that the main processes that are taking place here are a vertical style of erosion. You've not named the type of erosion, which could be hydraulic action or abrasion being the main 2, but you're saying it's mostly working in a downward action vertically, so it's pushing down. And that would mainly in the form of hydraulic action or abrasion or solution or attrition in the river channel, and that would result in a steep-sided valley. So vertical erosion, e.g. abrasion, hydraulic action in the river channel causing a steep-sided valley gets 1 mark. Okay, next diagram. So we're keeping these simple. 1 marks linked to 1 diagram in that last one. Weathering takes place, so we've got all these cracks on our vertical channel, which is vertical erosion taking place, and as it erodes downwards, the sides of the valley become exposed. So this is moving deeper, and these valley sides are exposed to freeze-thaw weathering. So explain it. You just talk about how water gets into cracks. It freezes and expands by 9%, and that loosens some of the rocks which fall into the river and steepen the valley sides. Okay, so that's 2 marks. So exposing the sides of the valley to freeze-thaw weathering, 1 mark. Explaining the process which loosens rocks and steepens the valley, that's 2. Okay, and then next diagram, what we get happening is something called mass movement. Mass movement just means when material moves down a slope. So this can be different types of landslide or landslip, or any material coming down a slope. Even within an avalanche you have mass movement too, because you have material moving underneath it. But we're talking about mass movement, it's just material moving down the valley. So gradually mass movement of material occurs down the valley sides, creating a V shape. So we've gone from this dotted line here, this vertical channel that's gone down, to a V shape with this material gradually sliding down into the river, where this thing acts like a travelator and takes this material away over time. And that's a mark. So rocks which have fallen into the river assist the process of abrasion. That should say corrasion, and they're not corrosion. So I maybe need to change that one. And this leads to further erosion. So remember, abrasion, not corrosion, it's corrasion if you want to use that one with an A. Last diagram. Eventually, the river transports the rocks downstream and the channel becomes wider and deeper. So effectively, you said how your process erosion that you talked about earlier on, how they work, deepen the channel. And this creates a V-shaped valley with in between interlocking spurs. I'm not going to go into great detail about these. The videos talked about interlocking spurs, and what they are bits of land that jut out into a valley. So if you put your knuckles together from above, they make a kind of wavy line in between them if you're looking down on your hands and looking at your knuckles where they're slotted together. And if you imagine your knuckles as being these interlocking spurs, bits that jut out, the river has to weave in between your knuckles or down between those points. And we'll have a look at that when we look at glaciation as well, in fact. And what actually happens in glaciation is when ice forms and a glacier occurs, it smashes through these spurs and it cuts them all off, and then they become truncated. I mean, that just means a cut-off spur, truncated spur. And we'll have a look at that during glaciation, so to give you a heads up for that. So make sure you've taken a note of your model diagram and model answers. All of those points here with a 1 next to them get you a mark. Remember, it's 8 marks, so you can choose your points accordingly. I suggest you have them all down around your diagram. Please submit to me a picture of your annotated diagrams as part of your work for today. And remember, send me any questions you've got or send me an email.